ago, when you did the derivative of that, you kind of did some substitution in your head. You just said, I'm imagining if this is something else, I'll do the derivative of the outside function. Okay? X cubed is like the inside function here. This is like the inside function. You do the derivative of this as though that's... We're going to do this. We're going to pretend that u is equal to this. Okay? Because then we can do the derivative of this with respect to u. And then times that by... And then times that by... What do I have to times it by? The derivative of this function with respect to x is the same as this with respect to u, and then du dx, right? Make sense?
What about the end of that? 5x fit over 2? No. Really? 3x to 5.
How do you not get this?
I thought I got it. It's the easiest thing I've ever done. Okay.
Make sure you understand how we're splitting this. Okay?
What's x cubed?
Okay. We need to rewind a few months here first, I think. Okay? Okay. Just go to YouTube. Yeah, I'll go have lunch. You guys just watch an old video. Give me some function here, whatever you want, as long as it's simple enough. X squared. Oh, x squared, it's so easy. I like that. Okay, the derivative with respect to... Oh, no, we need a kind of a chain rule type of function. How about sine of x squared? Okay. If you want the derivative of that with respect to x, please remember how you originally did the chain rule. You're so good at the chain rule now, although maybe you forget, that you just looked at this as something, right?
Look at it, it's something.
Look at it as something. Really what you're doing is you're thinking of it as some other variable, right? And you're saying, if I want to do the derivative of this, I have to do the derivative with respect to the something of that, and then times it by du dx. The only difference here is the function we have inside here is the inside function is now x cubed and the outside function is integral of something, right? It would actually be easier if we, on the calculator, if you use the kind of old notation, integral of something, where the variable is not just x anymore, it's x cubed now, right? The variable is x cubed. The variable isn't just x here, it's x cubed. You want the derivative with respect to x, but the variable is x cubed. Okay? The inside function is x cubed. X cubed is the inside function. So what we need, if we want the derivative with respect to x of this, I'm just using a u instead of x cubed here. But you could say the derivative with this with respect to x cubed times the derivative of x cubed compared to x. All right? The derivative of this is just whatever the u is, right? This thing is just what? It's just u. Right? We still have this whole thing here. This whole thing is just u. U.
Then who?
What's du dx here? 3x squared. What was u that we started with here? 3x to the fifth. The only difference here, because you guys said, can't you just sub the... Go back to what you said first. Can't you just put the x cubed in? That's what a lot of you, I think, said first. Can't you just put this in the way we did before?
No, you cannot.
You can't. I guess you can, but you have to know that since it's not just a variable itself, since you're doing the derivative with respect to x, but this says x cubed up here, you need to multiply by the derivative of that inside function, x cubed. Right? Remember when you had sine of x, the derivative was just cos of x. If you had sine of x to the fourth, you couldn't just say cos of x to the fourth. You had to do cos of x to the fourth times 4x cubed. Here you can't just sub in this as though you're finding the derivative, you need to multiply by the derivative of the inside function. X cubed is the inside function. Remember, that's the variable in that function. When you do integral from 1 to x of some w dw here, this is the variable. This is the function, right? If you wanted to make up some crazy notation for this, you could say integral 1 to x, right? That notation on the calculator from 1 to x, this is the variable. You'd have to put some other w as the variable here, except we have to put the function in. It's not going to work with my, now that I think about it, my calculator notation here. You can get it? Let's do this one. Well, this is generalizing it here. If you want the derivative with respect to x of this, it's just putting this in as that function. That, it's just the function, it's not just u. It's f of u. That's just rude. Times u prime, du dx, we should say, instead of u prime. That's good that you said that. Just make sure you say the f of, the of very clearly. Okay? Okay, so if you're working on this, if this was just x, you would just say it's sine x. So you can pretend like it's just, remember before we said you just treat that as something, right? And you put it in, right? Except here it's even easier because you don't even have to use any actual, you don't even have to know any derivatives, right? If this was just an x, this would just be sine of x. So let's pretend it's just that, and it's sine of x squared, but now we have to times by the derivative, right? You just put this in, because that's what the fundamental theorem of calculus says. The derivative of the integral of something is just that function itself, but since it's not just a variable, it is a function, it's the inside function we need times 2x. Or if you like to write it in the order it probably is written in the answer key, it's going to look like that. There's no what?
Oh, yeah. That's what I had to.
It's just 2 sine x in the answer key? The answer key is wrong.
Oh, you gotta change it. Thank you.
I'll remember to fix that after. Can we finish the rest of those and then more or less we're done with this unit here? You think about these things. I'll contemplate what we're going to do after.